So here I want to show you uh, two formulas, that is sine of minus theta is equal to minus sine theta and cos of minus theta is equal to cos theta. I'll show it to you how it works, but for now remember, sine of a negative angle is always negative of sine. Cos of a negative angle is the same thing. I'll show it to you how it works. Now guys, while doing this, please give me your undivided attention because otherwise it will be difficult to understand. Listen carefully, look carefully at the screen. Now, let me take so this is the angle. Angles will be shown here and here also. So let me take around 48 degree. Just look at the left side for now, okay? Leave the right side, just look at the left side for now, at the circle. So this is again a unit circle, so you can see one here, that means it's a unit circle. Let me take around 40 something, 48 degree, okay? Now let my theta be 48 degree. When my angle is 48 degree, if you look at carefully, my sine is positive because sine is vertical line. Vertical line is coming in the positive y direction, so this is a positive value. Cos is my horizontal line, and in a unit circle, cos is my horizontal line, and that is also positive because it is in this direction, first quadrant. X and y are positive, so my sine and cos are positive. Now this same angle, if I come negative, that means if I take theta is equal to minus 48, let us see what happens. So if I go back, theta is okay, minus 48. Now if you look, sine is the vertical value, but this vertical value is now coming down. This is the negative y direction, this is the fourth quadrant, negative y direction, so this value, sine value, will be negative. Okay, what about your cos value? Cos value is your horizontal direction, it is still in the positive x direction, so this will be positive. Now this is one of the proof that sine of minus theta is equal to minus sine theta, cos of minus theta is equal to cos theta itself. Now let me show you one more proof. I showed you the waves of sine and cos last class. Let me show it once more. Now let me show you a rough diagram. Okay, now guys, remember this blue one is, see, this blue one is sine, red one is cos, blue one is sine. Okay, now let me take example for sine. Sine is my blue one. For example, let me take 90 degree. Sine of 90 degree is 1. See, the graph shows sine of 90 degree is, blue is sine, so sine is 1. So according to the formula, sine of minus 90 should be minus 1. Let us check. This is 90 degree, this is minus 90 degree. Minus 90 degree, where is the blue graph? Minus 1. See, let me take another example. Sine of 270 degree. At 270 degree, 270 is here, this side. So at 270 degree, sine is negative, minus 1. At positive 270 degree, sine is minus 1. So what happens at negative 270 degree? At negative 270 degree, sine is positive 1. That means the negative of negative 1, that will be positive 1. So you see that sine of minus theta is equal to minus sine theta. Now let us check for cos. Cos, let me take 180 degree. Cos 180 degree is equal to minus 1. The red graph is cos. So cos my 180 degree is equal to -1. Now cos of minus 180 degree should also become -1. Then only our proof is true. So let us check. Cos of minus 180 degree is also equal to -1. Now, so what does that mean? Cos of minus theta is also equal to cos theta itself. No change. So cos of a negative angle doesn't change its value, but sine of a negative value will change its value. Okay, so let us come back to the PPT now. So in the PPT, waiting for us, there are a few more things. So these formulas are waiting for us. So we are going to study a few formulas that are, one is this. This is called the sine addition formula. Sine of a plus b is equal to sine a cos b plus cos a sine b. Now guys, I am not giving you the proof of this formula. Why? Because there is a proof, but if I show you the proof online, it will be confusing. If I show it in the PPT also, it will be confusing you. And so if any time I get a chance to show it to you on a blackboard, I will try to show it to you. For now, please study this formula as such. If anyone really needs a proof, just message me. I will help that person out of it. So sine of a plus b is equal to sine a cos b plus cos a sine b. What about sine of a minus b? Let us check. Now sine of a minus b, I can always write it as sine of a plus minus b. A minus b means a plus minus b. Now let me use this formula. Sine a cos minus b cos a sine of minus b. Now cos of minus theta is cos theta, so this will become cos b. Sine of minus theta is minus sine theta, so it will become minus sine b. So the formula will become tada. Sine of a minus b is equal to sine a cos b minus cos a sine b. Now let us do the same thing for cos addition formula. Cos a plus b is equal to cos a cos b minus sin a sin b. Now there's a tip to remember all this. That is, sin of a plus b, you always get plus here. If it is a plus, you will get plus. If it is minus, you will get minus here. In the case of cos, if it is a plus, you get minus here. It is the opposite. So that's one way to remember. Now what about cos of a minus b? Cos of a minus b is equal to cos of a plus minus b. So applying the formula, cos a cos of minus b minus sin a sin of minus b. So it will be cos of minus b is cos b itself, sin of minus b is minus sin b, and that minus will make this minus plus. Therefore the formula will become tada, cos of a minus b is equal to cos a cos b plus sin a sin b. So these are few formulas which you guys need to study now. Remember, this is a very basic formulas. With these formulas we can derive many other things, so please study these formulas. And yeah, so now we will move on to yet another thing, and we will see how unit circles, how to find, how what we saw about sine of minus theta and cos of minus theta, we will see what happens when the angles come in different quadrants. We will see to that. So let me draw my unit circle once more. First I will draw my line. So let me use a blue color, some different color. Let me draw my line. Okay, this is a little cool. I will mark this as my x-axis and this will be my y-axis. You all know this, right? Got Cartesian plane. Now I will draw my circle. I'll use a different color for that. Almost center. Perfect. Now I want you to see different things. We all know that this is a quadrant. These are Cartesian plane works on a quadrant. This is the first quadrant, and we know that this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. I hope you all already know that. In a graph, we have different quadrants, and here x is positive, y is positive. We know this is 0, so x is negative here. By the way, this is a unit circle. Okay, don't forget that all circles that we are drawing now are unit circles. So this is 1. I'll draw 1. I'll write 1 here for your information. Okay, this is third quadrant where x is negative, y is negative. This is fourth quadrant where x is positive, y is negative. I hope you all know that already. Now I will put the 0 here and 1 here for your understanding. Okay, now guys, look carefully. So we already came to know sine of minus theta is minus sine theta, cos of theta minus theta is cos theta, and all. But here I want to tell you what happens. For example, if I have an angle here, suppose I have a line like this. Okay, this thing makes an angle of around, I don't know, maybe around 45 degrees, I guess, around 45 degrees. But the question is will my sine be positive or negative here? Sine of this angle, let this angle be around theta. Okay, will the sine and cos be positive or negative? That is what I want to know. Let us look. Now if we look carefully, we will see that sine is slightly, my vertical length is sine, vertical is positive, this is positive y. My x-axis, my horizontal is also positive. Okay, so my sine is positive, my cos is positive. Now because sine and cos is positive, tan is also positive. Why? Tan is sine by cos. So great, tan is positive. Now what about cosec? Cosec is 1 by sine, that means 1 by positive. So cosec is also positive. Great. Now what about sec? Sec is 1 by cos, 1 by positive. Now what about tan? Sorry, cot. Cot is 1 by tan. So tan is positive, so cot will also be positive. Yeah, hooray. So all my trigonometric identities are positive in this part. I know I didn't tell you why it only comes in that part, and I'm going to tell you. But understand that here all my trigonometric identities are positive in this area, in the first quadrant. Okay, now let us leave all this. Let us take a new angle. Suppose, where is my line? Yeah, suppose my angle is this. This is my angle. Okay, this is pretty bad. sorry, this is not my angle, this is my angle. This is my angle. So looks pretty difficult, right? Now what will be my sine and cos and tan here? Think. See, my sine is my vertical line. Vertical is positive, pi is positive, so my sine is positive. What about my cos? Cos is this horizontal line. It comes in the negative side. This is 0, it comes the left side of 0. So this comes in the third quadrant, or it comes in the second quadrant. Therefore, my cos is negative. Now what will be tan? Tan is sine by cos, positive by negative. So tan will be negative. What about my cosec? Cosec will be 1 by sine, 1 by positive. Oh great, that is positive. Whew. Then what about sec? Sec is 1 by cos and 1 by negative, that will be negative. Cot is 1 by tan, tan is negative, so negative. So there's an interesting thing here. In this first quadrant, we thought, everything is positive, hey, and we were like so happy. But in the second quadrant, everything is not positive, and that makes a lot of difference, guys. Believe me, it makes a lot of difference. In the second quadrant, if I take an angle, and if I take an angle, the trigonometric identities except sine and cosec, all other trigonometric identities, the answer will be negative. I will prove this to you after some time, but for now you can see through this that except for sine and cosec, everything else will be negative. Everything else. Now let us leave all this. Let us take another angle. We'll go through each quadrant like this. So let me take a third quadrant. Okay, and let me draw my angle. This, see, we should always start our angle from the same point. Okay, that is why this is our reference. Remember, this is our reference. So our angle starts like this. So all our angles, start going like this. All start from this area. Okay. Now this is our angle. What to do? Now, okay, just I forgot to tell you this before. When our angle was this, you should know that this is actually, these type of angles we write it as 90 plus theta. You get it? This angle is actually 90. Here full 90 is there. 90, full 90 plus some angle, depends on which line is like this, theta will vary. Line is like this, theta will vary. So depending on the line, depending on the point, theta will vary, but full 90 will be there. So these type of angles, the angles in the second quadrant, we call it as 90 degree plus theta. This is how we represent it, 90 degree plus theta. Okay, because the full 90 is there, then it is some theta. Because now let me clear this. So coming back, we will draw a line in the third quadrant. Okay, I think we got shifted to red color, and that is fine. So this is my angle. Now let us check. If I check carefully, I see that my sine is vertical line. A vertical line comes like this. It comes in the other direction of y. So my sine is negative. So sine is negative. What about my cos? Horizontal line. That is also negative. Very bad. Negative. What about my tan? Tan is sine by cos. Hey, sine is negative, cos is negative. So negative by negative is positive. So tan is positive. What about my cosec? Cosec is 1 by sine, 1 by negative. Negative. What about my sec? 1 by cos. Negative. No. And what about my cot? Cot is 1 by tan. Hey, that's positive. So we see that in the third quadrant, only tan and cot are positive. Except for tan and cot, everything else, every other trigonometric identity is negative. Okay. Now these type of angles, we write it as 180 plus theta. Why? Because already this much angle is covered. This is 180 degree. After that, some angle will be covered depending on the point. The theta will vary. So these type of angles in the third quadrant, we call it, we write it as 180 degree plus theta. Okay. Now let us go for the next one. Here. So if I draw now, if I come back, after going through all the circle, if I come back to the fourth quadrant, this will be my angle. Okay. Now what to do? Let us check again. So coming back and checking about our cos and tan and blah blah blah, we come to see that sine is no way, sine is negative. Why? So sine is negative. Cos is positive, comes in this direction. Okay, cos is positive. What about tan? Tan is sine by cos, negative by positive, negative. Cosec 1 by sine, that is 1 by positive. Sorry, 1 by negative, that is negative. Sec is 1 by cos and 1 by positive, therefore it is positive. What about by cot? Cot is 1 by tan, that is 1 by negative, and it is negative. So in the fourth quadrant, I see that only my cos and sec are positive. Except for cos and sec, every other trigonometric trigonometric ratio is negative. So these type of angles, we will write it as 270 degree plus, okay, theta. Why 270 came? This much is covered, right? This is 180 degree. Then this much is covered. This is 90 degree. 180 plus 90. 180 plus 90 is 270. So 270 degree plus this much, that is theta. Depending on the line, it will vary. So these type of the angles in the fourth quadrant, we write it as 270 plus theta. Otherwise there are other ways to write it. That is, I can come from this side. So a complete revolution is 360 degree, right? So I can write 360 minus this. I can also write it as 360 minus theta in the fourth quadrant, because of 360, see, basically 360 is like 0 degree only, because you come back at the same point, then I go back a bit, that is 360. So there are two ways of looking at it. Okay, now let me show you. I can't show you the proof of everything, not because there are proofs, but it will take a lot of time to show you, and you will and by the time I finish showing everything, you will be sleeping. So I will show you the proof for whatever I showed you now for sine and cos. Okay, the rest of the things, if you really want to know, and if you have a doubt, and if you really want to know, you can ask me. I'll make a separate video for the person who asks. Okay. Now if you ask me, sir, what is the use of what all we studied now, why this quadrant difference and all, let me tell you. For example, I told you sine of 90 minus theta. Oh, wait. We already studied our radians. Let us write in radians. I already told you that sine of pi by 2 minus theta is equal to sine theta. Sorry, is equal to cos theta. Right, you studied this last year also. But now I'm telling you what is sine by pi by 2 plus theta. Now pi by 2 is 90 degree. Okay, so what is sine pi by 2 plus theta? It is basically in the second quadrant, 90 plus theta. So second quadrant, you know, sine is positive, so it will be cos theta. It is sine, you know, when you add 90 it becomes cos, and the sine will be positive because sine in the second quadrant is positive. What about the third quadrant? If it was sine, you know, okay, I'll show that to you in a larger picture. What would happen if it was sine of pi plus theta? See, here I will tell you a small tip. Whenever pi by 2 comes, the function changes, and if it is only pi, the function doesn't change. That means if it is sine, you know, pi by theta, or sine, you know, 180, sine pi by pi plus theta means 180 plus theta, same thing. So it will still remain sine. Okay, sine theta. It will not become cos or tan or anything. Sine, when the 180 comes, see, the value changes only when 90, 270, all such things come. If it is 180, 360 and all, the function doesn't change. So this 180 plus theta is in the third quadrant, right? 180 plus theta. Now third quadrant sign is negative, so therefore this answer will be negative, but the function will still remain sine. Now I know it is a little bit confusing. I will show it to you. I'll show it to you soon. Yep, I'll show it to you soon. So remember, whenever it is 180 or multiples of 180, that means, you know, 180, 360, 360 plus 180 plus 180, like that. For example, pi, 2 pi, 4 pi, 6 pi, 8 pi. In all these cases, the function doesn't change. But if it is pi by 2 or 3 pi by 2 or 5 pi by 2, you get it. You know, so in those cases, 90 degree, 270 degree, the function changes. Sine becomes cos, cos becomes sine, tan becomes cot, cot becomes tan, sec becomes cosec. But the sign, whether it is positive or negative, it is dependent on which quadrant it is. One short form to remember this is, there are many short forms. One short form is the famous short form all silver tea cups. If you take the first letter of all these things, A, S, T, C, you will understand which is positive in each quadrant. In the first quadrant, all are positive. In the second quadrant, sine is positive, and therefore the reciprocal of sine, that is cosec, is also positive. In the third quadrant, tan is positive, therefore the reciprocal of tan, cot, is also positive. In the fourth quadrant, cos is positive, and therefore the reciprocal of cos, sec, is also positive. This is one way to remember it. Another short form is, which you can use whichever you want. After school comes college. Here also, all sine. Sorry, I'm sorry, it is not comes, it is after school, then college. I'm sorry. That means T and C, all sine, tan, cos. You can use whichever you want you can use, or some people just remember it as ASTC, all sine, tan, cos. You can use it whichever you want, and you can. It does not depend necessarily that you need to use a short form itself. If you can remember it, otherwise, your wish. So always remember that your sign value depends on which quadrant it is. Okay. Now, for example, I'll show you what is tan pi by 2 plus x. Now it is pi by 2, therefore the function will change. So it will be cot x. Now whether it will be positive or negative, 90 plus x, it is in the second quadrant. Second quadrant, tan is negative, so the value will be negative. Let's go for another example. Sine, okay, leave sine, I've been doing this sine a long time. Cosec of 180 degree, or let me do a different one. Cosec of 200 degree. How to find? Cosec of 200 degree is equal to cosec of 180 degree plus 20 degree, right? Now 180 degree means the function doesn't change, so the answer will be cosec of 20 degree. Now the value will be positive or negative. 180 plus theta. 180 plus theta means third quadrant. In the third quadrant, cosec is negative, so this will be negative. Negative cosec 20 degree. So this is how you do it, and yeah.